A non-condensable gas is found. A. Above the critical point. B. Below the critical point. C. On the critical point. D. None of the mentioned. The correct answer is above the critical point. Representation of the different phase of a compound on a 2 or 3-dimensional graph is A. Block diagram. B. Equilibrium diagram. C. Phase diagram. D. None of the mentioned. The correct answer is phase diagram. The change of phase from liquid to vapor is called A. Boiling. B. Melting. C. Condensation. D. None of the mentioned. The correct answer is boiling. Is the temperature at which a liquid just starts to vaporize A. Critical point. B. Bubble point. C. Triple point. D. Saturation point. The correct answer is bubble point. The 1-PTV combination at which solid, liquid, and vapor are in equilibrium is called A. Critical point. B. Triple point. C. Saturation point. D. None of the mentioned. The correct answer is triple point. Is the temperature at which the vapor just begins to condense at a specified pressure that is the valued temperature along the vapor pressure curve A. Dew point. B. Bubble point. C. Triple point. D. Critical point. The correct answer is dew point. If the vapor and liquid of a pure component are in equilibrium, the equilibrium pressure is called A. Partial pressure. B. Vapor pressure. C. Liquid pressure. D. None of the mentioned. The correct answer is vapor pressure. Incorrect statement about a phase diagram is A. Phase diagram are based on equilibrium conditions. B. For phase equilibrium it is assumed that the phase doesn't remain invariant. C. Phase diagrams enable to view the properties of two or more phases as a function of temperature, pressure, and other variable. D. None of the mentioned. The correct answer is for phase equilibrium it is assumed that the phase doesn't remain invariant. Find the incorrect statement for condensation. Other change of phase from vapor to liquid. B. Occurs at constant temperature and pressure. C. The process appears as a point in a PT diagram. D. All of the mentioned. The correct answer is all of the mentioned. At a given temperature there is only pressure at which the vapor and liquid phases of a pure substances may exist in equilibrium. A3. B2. C1. D. None of the mentioned. The correct answer is 1.